हैं risk processor. risk processors क्या होते हैं? risk processors is actually a term which is being used, reduced instruction set computer. All right, reduced instruction set computer, risk processors. ठीक है जनाब. अब ये जो हमारे पास कंप्यूटर्स आजकल हैं ये तो थोड़े से डिफरेंट हैं, ये पूरे रिस्क नहीं है, लेकिन समटाइम्स कुछ कंप्यूटर्स हमारे आसपास मौजूद होते हैं, स्पेशली जो पुराने वाले सेल फोन्स हैं वो रिस्क बेस्ड ही होते हैं. सो बेसिकली 3.3.5 रिस्क प्रोसेसर्स. तो रिस्क एंड CISC processor. Pehla show understanding of the difference between RISC and CISC processors. So early computers made use of one Neumann architecture that we studied in AS. Modern advances in computer technology have led to much more complex processor design, obviously. Two basic philosophies have emerged over the last few years. Last few years, by saying last few years, I don't mean last few years as in 4, 5, 10 years. I mean that last few years means 4 decades, 3, 4 decades. Okay. Two basic philosophies have emerged. Number one, developers who want the emphasis to be on the hardware. Developers who want the emphasis over the hardware. Who are these developers who actually rely on hardware? These are gaming developers. These are operating system developers. These are those developers which are actually making hardware, or these making sophisticated hardware devices like robots, car systems, ECUs, and any gadget that is based on the control by the computer or microcontrollers, not those programs which you make for your string manipulation or accounting and journal system processing and office working, not those. So certainly if we are playing game, we are looking after their GPU concept. So that means that these games are based on hardware. So there is a clan of developers who want the emphasis to be on the hardware used. The hardware should be chosen to suit the high-end language development. Okay. And there are developers who want the emphasis to be on the software or the instruction set to be used. The philosophy is driven by ever faster execution time. आपको पता है कि जो सुपर कंप्यूटर है, we don't count its speed in terms of megahertz or gigahertz or number of operations per second. Rather, we count its speed in terms of flops, floating point operations per second, because anything which is hardware based must be actually stressing the hardware, and hardware is actually being judged by the result produced in terms of mathematics, not operations. Anyways, we will discuss that later. So let me revise. Early computers made use of one Neumann architecture. Modern devices in computer technology have led to much more complex processor design. The two basic philosophies have emerged over the last few years. Number one, developers who want the emphasis to be on the hardware used, means the hardware should be chosen to suit the high level language development. Means first we will decide for hardware and then we will go for development. Secondly, developers who want the emphasis to be on the software to be used. This means that this philosophy is driven by ever faster execution times. Means that we actually develop and we expect that computer will execute it faster, rather than paying attention to hardware. We pay attention to our work and then we actually depend on computer, how fast that computer. So the first philosophy is part of the group of processor architecture known as CISC. CISC is C-I-S-K. C-I-S-K over here. CISC. The first philosophy is part of a group of processor architectures known as CISC. Basically, IBM started the whole idea. IBM, now not known that much, but IBM started the idea. The second philosophy is part of the group of processor architectures called RISC, Reduced Instruction Set Computers. Now, CISC processors architecture makes use of more internal instruction formats than RISC. I'll explain everything, just be with me, hold on. The design philosophy is to carry out a given task with as few lines of assembly code as possible. Remember that in the hardware, especially in this chapter, the instruction that we are referring to, instruction set that we are referring to, the language that we are referring to is nothing but assembly language. We are not paying any attention to any other language, just the assembly language, because that is the language of hardware. CISC, complex instruction set computer, processor architecture makes use of more internal instructions formats than RISC. The design philosophy is to carry out a given task with as few lines of assembly code as possible. Processor hardware must therefore be capable of handling more complex assembly code instructions. Essentially, CISC architecture is based on single complex instructions set which need to be converted by the processor into number of sub-instructions to carry out the required operation. I'll explain it further. For example, suppose we wish to add two numbers, A and B, load A and then add B, or that is RISC, two instructions, load A, which we have been doing, load A, add B. But if it is complex instruction set code, the instruction would be add A comma B. Add A comma B means there is just one instruction used and now we are relying on processor to do it its way. But in RISC, processor is not being relied on, that not being dependent over, rather what we do, we are dependent over our own understanding and the logic. We drive the whole car. In CISC, we just tell the computer, computer does it. This methodology leads to shorter coding that is called RISC, reduced instruction set code, but may actually lead to more work being carried out. RISC processors have fewer built-in instructions formats than CISC. This can lead to higher processor performance. The RISC design philosophy is built on the use of less complex instructions, which is done by breaking up the assembly code instruction into number of simple single cycle instructions. Ultimately, this means there is smaller but more optimized set of instructions than CISC. अब इस पे हम बात करते हैं. Please give me some time. Let me load the instruction set of RISC and CISC to make you understand it. अच्छा, अब आप देखें, number one, reduce instruction set code and complex instruction set code. Reduce instruction set code is strenuous for hardware, and complex instruction set code is strenuous for hardware, whereas reduce instruction set code is tough for programmers. ठीक है? So complex instruction set computer or code is CISC, reduced instruction set computer or code is RISC. If you pay attention to this code, that I hope that you would understand easily. This is LDM. Load immediate 63. So 63 is being loaded. Then you added 64 to it. This is immediate. We are not referring to any memory, rather we are just. Then product 29. Product means that whatever that is present at the address 29 will be added to the accumulator, will be multiplied with whatever is in accumulator. And what would be the accumulator? The addition of 63 and 64. Afterwards, whatever the result, that result, let's say R4 is the name of a register. The way we can name memory addresses, we have names of the processor registers as well. So there is a processor register called R4, register 4. So the content of the register 4 will be multiplied with the content of accumulator, and then whatever the result that will be stored at location 23. So first of all, what happened? LDM 63, accumulator is loaded with 63. Number 2, then whatever the data in accumulator, that is 63, will be added with 64, and now the data is in accumulator, the result of addition of 63 and 64. Then whatever is present at the address 29 will be multiplied by the content of the accumulator, and the result would be in accumulator. Then afterwards over here, the content of register 4, R4, will be multiplied with the content of accumulator, and that will be stored in accumulator as well. And then whatever the result of accumulator will be stored at the address 23. So how many instructions are these? 1, 2, 3, 4, 5. This is reduce instruction set code, means easy instructions. Rather than writing a single instruction, we just wrote many instructions. Means that we have to write larger code to get the same thing. On contrary, if you look at RISC, CISC, if you look at CISC, so there is just one single instruction. That instruction says that multiply whatever in 23 and 29 with the 63 plus 64. And sorry, 23 is the storage. First thing in complex instruction code is the address of the location where you have to actually put the data back. Sorry. So now you can see this instruction. What will happen? 63 and 64 will be added first, and then they will be multiplied with 29. The result will be multiplied by the content of R4, and the whole thing is then saved to 23rd location, address 23 in memory. So how many instructions are there? One. But that one instruction is complex. Why it is complex? Because now the programmer is expecting processor to do the rest. Over here, all processor has to do is just to follow one instruction at a time, and that's it, no more complexities. But over here, processor first has to figure out how to basically break up this one instruction into number of instructions, and then execute it. So what is happening? In RISC, the programmer is breaking the instructions and processor is just following it. In CISC, what is happening? That the programmer is giving one single complex instruction, and processor has now this duty to break that into number of instructions, and then these instructions will be executed by the processor one by one. So we can understand it easily by ourselves that the code in CISC is shorter because we have to write fewer lines, but the code in RISC is larger because we have to write more lines. Which is easier? It's up to the programmer, because these are two philosophies. We tend to look at things by our own perspective. So few of the programmers are basically in favor of CISC and few of the programmers are in favor of RISC. We as users, as the user of made program, we don't care about it, but when it is being programmed, when it is, we as the user of made programs, we as the user of the program which are downloadable and execution, are not very much concerned with it, but those who are making programs, developing programs, writing source code are actually concerned about it. Now, this is all old thing. Nowadays, the processors are hybrid. So sometimes they are using RISC, sometimes they are using CISC, but we have to study it in terms of what our syllabus require. So let's see. Now, I have put 4 points on each side. Number one, this is flexible instruction size. You need to remember in AS what happened that we studied that there is a bit size of the, which we call word size. There is a fixed bit sized system that is 32 bits, that is 64 bits. So the instruction that we write is actually having a ratio of 5 to 3. If you do remember, in 32 bits, 20 bits are allocated for opcode and 12 bits are for operand. And that is why we had this indirect addressing thing and all. If you do remember that, out of that compulsion, whatever the instruction that we write in RISC, the operand should be of 12 bits. Over here, this is operand, and opcode should be of 20 bits. Okay, but in CISC, that limitation is lifted. Now you can write the instruction as big as required, as complex as required. The size is flexible. Why it is flexible? Because then processor will break it to the word size. Over here, we are given by that instruction set, which is for that processor word size. But over here, we are flexible. When we write more, processor breaks it itself. Over here, when we write, we have to write the way the processor wants it. So processor is doing itself, here we are doing itself. So this is flexible instructions size, over here it is fixed instruction size. Then whatever that we write is short code, over here whatever we write is larger code. We also discussed it. Over here compiler does less, because all compiler do is just convert this complex instruction to the binary form, which is still complex. Then the processor, this is the processor. Every processor has got a firmware. Now what is a firmware? Firmware is the software which is built in the processor by the manufacturer of the processor, and the first and foremost task of this firmware is to break a complex instruction into microcode. What is microcode? Microcode is making a complex instructions code in the form which is simpler instruction code. So when we do it, we call it RISC. When computer does it, computer calls it microcode. All right. So in RISC, what happens that you write complex code, compiler converts that complex code to the complex binary form, and then complex binary form passes through the firmware in the processor and turns into microcode. This is the additional strenuous work that processor has to do, and that work is not there in this RISC, because over here every instruction is in the exact size which is required by the processor. Our processor does is just to convert it. So over here compiler does less, over here compiler does more. Why compiler does more? Because there are more instructions. Here the number of instructions is less, so compiler, what compiler does? Compiler turns an assembly language instruction to its binary form. So when there are less number of instructions, less work for compiler. In RISC, there is high number of instructions, so more work for compiler. So that is why compiler does less over here and compiler does more over here. Now this is favorable for high level languages. High level languages like Python, Visual Basic, Java, AI applications and all that we use nowadays. Just think about it. If we would have to write the simpler code, the program that you would have written, if they will be written in the form of assembly language program, you will be bitten by the length of the programs. So what actually happens that high level languages nowadays are not based on this. We have already studied that whatever that we do in high level languages is in short code, and if you convert it to the assembly language way, you would have to write the more code. So high level languages by default support complex instruction set code. So high level languages are built on top of complex instructions set code, whereas assembly language is built on reduce instruction set code, and that is, we know that whatever that you do, ultimately processor has to convert everything the way the assembly of that processor requires. Okay, so less effort by the programmer. Obviously programmer has to write less code. Over here the programmer has to write more code. So now we know that this processor, CISC processor bears a firmware thing. The firmware breaks the complex instruction to the form which is easier to be executed by the processor, whereas in RISC the programmer itself writes the code that is simpler. Now processor does more. Over here processor does less, because processor would have the extra duty of converting the complex code to microcode. Over here, high heat generation. Now this is another indication. So all those devices which have coolers in it, which have fans in it to cool down, those are made up of what? CISC. But you can see that these handheld devices like your iPads and tabs and cell phone, they do not have fan in it. So it means that these devices are more RISC oriented than CISC oriented. But if you have got a desktop and laptop, they might have fans outlets in it. They might have heat sinks in it. Nowadays, I'm not actually referring to the modern cell phone in terms of latest phone, because they have heat sink as well. And nowadays, hybrid means CISC and RISC, they both are being used by the processor nowadays. So let's just generalize it in common sense. In common sense, all those devices which are having ways to get rid of heat are basically CISC heavy, because processor is doing more. When the processor is doing more electrons are being flown. There is more friction. When there is more friction, there is more heat. When there is heat, you have to get rid of the heat, extend the heat. Whereas in RISC, processor is doing less, there is less heat. Less heat can be get ridden of by just the chassis, or maybe the whatever kya kahenge isko, casing that the device has. That casing would be enough to dismantle, or what do we say, not dismantle, in a to neutralize the heat and all. So requires cooling system. It does not require a cooling system. So all the desktops and laptops with the fans and all, they are actually having CISC, whereas over here casings are enough to pacify the heat. Bigger instruction set code. Bigger instruction set code means that you have more instructions. You have got so many instructions. And in RISC, you have got reduced instruction, means less instruction. What does it mean? Pay attention to this thing. This is very important. In CISC, this firmware converts the code to the reduced instruction set code. There is no control unit, and there is one separate circuit for every instruction. Whereas in CISC, there is a control unit, and that is responsible for the execution of the instructions. So all instructions are being executed by the control unit through its circuitry and all, but in RISC, there is a separate circuit for every instruction. So having a separate circuit for every instruction actually will put compulsion, because we cannot have enough number of instructions, because we have got the size restricted to the size of the processor. आप समझ रहे हैं ना कि अगर एक इंस्ट्रक्शन के साथ एक सर्किट है, तो हमारे पास बस इतने ही सर्किट आ सकते हैं जितना कि हम उस प्रोसेसर के साइज में समा दें, उससे ज्यादा सर्किट्स नहीं आ सकते. जबकि RISC में there is no such limitation. Control unit is doing it, so you may have any number of instructions. सही हो गया. बिगर इंस्ट्रक्शन सेट मतलब हमारे पास ज्यादा इंस्ट्रक्शंस हैं, यहाँ पे कम इंस्ट्रक्शंस हैं. मेमोरी टू मेमोरी, मीन्स देखें अभी क्या होता है कि अभी हम डेटा को जो है वो लेकर आते हैं मेमोरी से प्रोसेसर में, डेटा को हम लेकर आते हैं मेमोरी से प्रोसेसर में, और फिर हम उसको जो है प्रोसेस करते हैं और फिर प्रोसेसर से लेकर जाते हैं वापस मेमोरी में रख देते हैं। तो ये क्या होता है जिसको हम कहते हैं रिस्क में जो हमने पढ़ा है वॉन न्यूमैन आर्किटेक्चर में, दैट first we have to load the data to accumulator with LDM, LDD, LDI, LDX, LDR, and then we process it in the registers, and then afterwards at the end we store it back to the memory. So this is called register to register working. Whereas in CISC what happens that we actually don't load and work and put it back, rather we say that pick from this memory address and store in this memory address. So what is happening that we are over here, if you pay attention, pick from 29 from R4, take these two, and then result will be put back in the memory address mentioned over here at the start. So it means that this is memory to memory. So load and store operations are now built in. We don't have to actually do anything to load or store back. Rather, just all we have to do is to just write that pick from these memory locations and put back in this memory location, and whereas perform this operation on top of it. So get the idea. So this is called in CISC memory to memory. In RISC it is called register to register. All right. So now production of the microprocessor. Production of the microprocessor as Intel produces it, as in Qualcomm produces it, as in Samsung produces it. So when they produce CISC, obviously it is complex production. If it is complex production, it is expensive. Whereas RISC processors are easy to produce because the circuitry is there and it is simpler and all. So because of its simple method of production, they are cheaper. They are cheap as in less expensive. So last few points. Over here, single instruction is executed in multiple cycles. Now this is very important, that you have given one instruction in complex instruction set code, and then firmware will break it into number of microcodes or number of multiple instructions. So it means that one instruction will be executed in multiple cycles. What cycles? Fetch, decode, execute cycle. As you can see over here, in RISC we have got how many instructions there? 1, 2, 3, 4, 5. These 5 instructions will be executed one instruction in one cycle at a time, finished. Whereas this particular instruction will be, this is one instruction and it will be executed in 5 instruction cycles. Why? Because computer will first pass it through firmware to find the microcode. So one instruction of CISC takes many cycles to complete, whereas one instruction in CISC takes single cycle to complete. Then you would have your points to explain and all, but you need to pay attention to it. All right. And then uses control unit. I did explain it that CISC has got a control unit that does multi-clock cycles per instruction to complete the execution of the program, whereas in RISC, separate unit for every instruction. Whereas in RISC, there are separate unit for every instruction, and single clock cycle per instruction is used. And there are many types of instructions are available for memory addressing, and in RISC there is just 2 types of instructions for load and instruction. No, not 2 types. There are like LDM, LDR, LDX, LDI, and what else? That's it. 4 or 5 types. But over here there are more than that. So we can refer to memory locations and register locations in more ways than those are available in RISC. All right, and then in CISC, micro program controller, and over here hardwired control unit. What does it mean that over here the control unit is actually micro programmed firmware based. Over here it is hardwired control unit. That control unit only knows, let's don't call it control unit sometimes, rather it's just a unit that is controlling, that it takes one instruction and send it to the respective circuit to execute that instruction. Over here there are no respective circuits, it is microprogrammed, so it does it itself. Pipelining is difficult, pipelining is easier. Now what is pipelining? This would be related to another topic later, we will do it tomorrow and all. So